Alright, speech class is my informative speech. These are my depictions that I'll show in a minute. Alright, let's start. Okay, in order to safely dock the International Space Station, some crucial orbital mechanics and physics have to be calculated first. Those four main physics and calculations all add up to the launch, the Hohmann transfer process, a series of correction burns, and phasing orbit. So I'll elaborate more on those in the illustrations that I showed in the beginning of the video. Hopefully you'll be able to depict the correct one at the end, showing you that my informative speech was informative. So there are three basic examples of ways that people think that the Soyuz shuttle, which is the only shuttle that we launched the International Space Station now, gets there, and most people think it's like a straight flight, which is what one of those depictions were. Another one's like an orbital flight that gets right to it, and then the last one was the actual process, which has the phasing orbit and the correction burns and all that. So leading into that, most of us have seen the movies The Martian or Interstellar, where humans were forced to live in space or on other planets desperately to try to find a sustainable life source. Although this was only a movie for now, this is right around the corner. This is our exploration. These are our space days. So the studies to do that all start with the International Space Station. If it wasn't for the International Space Station with zero gravity and all that, we would not understand how to actually get somebody to Mars and make that endeavor. Moving forward, the International Space Station has always puzzled me because of my current assignment. I've taken this opportunity to elaborate more within my subject and enlighten myself to the information. So I have done rigorous research, such as go to the Smithsonian Institute of Technology for the air portion of it. That was about a year ago I did that. I did some rigorous research on NASA on their site, and then also watched quite a bit of videos to try to figure out more about the actual flight. So the first part is the launch. To launch the rocket into orbit, it takes those massive thrusters that you see on the side, and it actually takes 9.5 minutes to get from the Earth to out of Earth's strong pull. You're still in orbit, but it's not strong enough to pull you back down to Earth. This is when those boosters will fall off, and you'll actually just be using thrusters at this point and no longer large boost packs to get up there. The second step is the Hohmann transfer process. The Hohmann transfer process is using like burns, which are small thrusters that are arranged outside of the ship. These help to enlarge the distance from Earth. It actually does a specific amount of 7 burns to realign itself to get to the ultimate position where it lines up with it. The first 2 burns of this are to distance itself from Earth, and it finally corrects itself to get it to its certain distance for the next process, which is going to be the Hohmann transfer process. But since those boosters that we were talking about are different sizes for each shuttle, that's why they have to use thrusters for each one. That's why some will be 7, some will be 9 thrusts. Those different boosters, the gas in each one makes the difference. In this case, the shuttle only needed to do 1 burn to actually correct itself, to put itself on orbit for the next process that I was just talking about, and this would lead us up to the final process, which is the phasing orbit, which is the 4th and final step. This is where the shuttle actually catches up to it, does that full U-turn, and then finally realigns with it, doing like the maybe last few burns or transfer processes if needed. Normally it's not needed at that point, and then it just goes from there to a half an hour to an hour-long process because to dock to the actual International Space Station, because everything's moving at 17,000 miles an hour. So one flaw at that speed could literally implode or explode everything depending on where it hits. So they fly like an aircraft at that point, like constantly going in and backing up, going in and backing up to get the correct alignment. So again, we have docked the International Space Station. This is how you get there. And let's show my 3 depictions again and see if that launch, Hohmann transfer, burns process, and docking all lead up to this. so you guys can all look. And the correct one is this one. With the 3 rings, it does a U-turn, finally gets on the correct orbit, and then is able to dock. This one is an example of what a straight flight would look like, and this is an example of what one phasing orbit would look like. Thank you, everybody.